In number 41, this is a word problem, a pendulum type problem, where we have a ball on a string swinging from the ceiling. First thing that we're going to do is set up a graph to collect the information that we need to go on. It says let D represent the distance that the ball is from the wall at time t. Therefore, D is our vertical axis or dependent variable, and t, time, is our independent variable. It says to assume that D varies sinusoidally with time. Now it's going to give us some data to put on our graph. At t equals 0 seconds, the ball is farthest from the wall, or D equals 160 centimeters. At t equals 3 seconds, the ball is closest to the wall, or D equals 20 centimeters. And at t equals 6 seconds, again the ball is farthest from the wall at D equals 160 centimeters. Now, if we connect these, we see that this represents a cosine function that looks like that. Now, our maximum, according to this cosine function, is 160. Our midline is halfway between 20 and 160, which would be 90. Our minimum is 20. And the period, which of course is horizontally the length of one full cycle, here is 6 seconds. Now from this information, we can identify A, B, and C, and D so that we can write our equation. Our A value, or our amplitude, is the difference between the midline and the max, or the midline and the min. From 90 to 160 gives us an A of 70. B is calculated from the period. Remember, period is equal to 2 pi over B. In this case, period equals 6, or 6 over 1, so we can solve for B. Do cross multiplication, and we get 6b equals 2 pi. Divide both sides by 6, and B is equal to pi over 3. Our C value is our phase shift, and since our first calculation, or our first measurement, occurred at time equals 0, there is no phase shift, so our C value is 0. Our D value is our midline, which was 90. Remember, 90 came from an average of the two values, 160 and 20. Add those two up, you get 180, divide by 2, and you get 90. Now that we have A, B, C, and D, we can write our equation. We already took care of part A, which was sketch the graph. Now we're going to write the function. The function's going to look like this. Y equals, this is a positive cosine function, so we have 70 cosine pi over 3 theta. There is no phase shift, so we just get plus 90, which is our vertical shift or vertical translation. In part C, it says what is the distance of the ball from the wall at t equals 5 seconds. What you want to do for this, remember we have the use of our calculator. We should be in radians. And what we're going to do, the easiest way to do this would either be to look in your data table, which remember you can find in second graph. That's after you put the equation in y equals. Or you can do second trace number 1 value, and when it asks x equals, put in 5. The answer that you should get is y equals 125, and remember that's in terms of centimeters. Now that would be our answer for part C. In part D, it asks what is the value of t the first time the ball is 40 centimeters from the wall. They want your answer to 3 places after the decimal point. The way to go about this part would be to go to y2 in your calculator and set that equal to 40. When you graph it again, you're going to get a line that appears horizontally at 40 on your graph. They asked for the first time the ball hits 40 centimeters from the wall. So we're looking for this point right here. The way to find that is to do second trace, number 5, intersect. When the cursor shows up, move the cursor as close to that point of intersection as you can, and then hit enter 3 times. The first time it identifies one of the curves, the second time it jumps to the other curve, and the third time it finds the intersection of the 2. If you do that, you should get an x value of 2.260, and that's in terms of seconds.